Okay, today's video is Pearson Edexcel International A-Level from January 2025. It's the final January 2025 exam that I haven't yet done. So I think the Unit 5 exam is in early June. So it's in time for you to use this for your preparation. So Unit 5 contains thermodynamics, radiation, oscillations, and cosmology. So it's similar to linear. It's similar to linear advanced to A-level. So students preparing for linear A-level, you'll find that this will really help you with the year 13 content of your exam. Okay, so you'll also obviously need to refresh your memories if you're doing the linear exam on the year 12 topics that are aligned with linear advanced 2. So because the international A-level students do not have to revise their year 12 stuff, except they need to know the concepts, they won't get questions on the year 12 content as such. That means sometimes there's more depth in the international A-level, so it's a really good training for the linear students. Okay, so, and also there are more international A-level exams than there are linear exams. That's international A-level physics have 3 exams a year, January, June, and October, whereas linear is just in June. Okay, so let's get straight into it, and hopefully this will help you prepare whichever Edexcel exam you're going for. The syllabuses, the specifications are almost identical except for optics in year 12 that linear students need and international A-level students don't need. So this is about a main sequence star and its evolution into a red giant star. Okay, so which row of the table gives the change in diameter? Yeah. And also the change in surface temperature of the star when it evolves from a main sequence to a red giant. So the diameter of the star, obviously in the red giant, by its name, you can work out that it must increase. So it's got to be C or D. Okay, so the question is, does the surface temperature decrease or increase? The surface temperature of an expanding gas, it decreases. Okay, so expansion actually causes part of the reason why it decreases. Okay, and you don't need to know the rest of it for this question, so the answer is C. Okay, that's where you should put your X. So remember, this is how you do your answers, yeah, or if you want to correct them, tells you what to do, so make sure you've read the blurb at the top. So question 2 is about ductile materials. So you need to know that ductile materials undergo plastic deformation. So that's what ductility means you can pull them into a wire, yeah? And they can be used in buildings to reduce the amplitude of forced oscillations. So if there's vibrations in the building, ductile materials can absorb that energy, okay? So which of the following is the reason that ductile materials are used? It's D. These materials deform plastically, and plastic deformation, remember when you do a graph, yeah, plastic deformation is when you do the line, it goes like that, and obviously the energy of stress strain, yes, so stress strain looks like that, and the energy underneath it is the area underneath it is equal to the energy that is stored in it elastically. Okay, so you want one which is deforms plastically to absorb the material. So it's not because they're stiff. It's not because they're stiff. It's not because they're strong. And it's not because they're elastic. You don't really want it. You want it to be plastic behavior. So the answer to question 2 is D. So you need to know these key terms in science when you're revising, and if you haven't made good notes, then now is the time to use the multiple exam questions that you tried in your final part of your exam preparation is to make a note of any words that come up in exams that you didn't know before, okay? And right now, all you should be doing is past exam questions, improving your notes or making a concise set of notes on the things that you still don't know. So the electric field, yeah, and the gravitational field is what this question is, but it's around a point charge and a point mass. Okay, so a point charge and a point mass assumes all the charge to be acting at the center of an object. Yeah, well, obviously it's a point mass, it's only got 1 point. But for example, if you're looking at the Earth's gravitational field, we assume all the mass is acting at the center of mass of the object. So both of these are radial because the electric field decreases with distance. Yeah. If you think about it, if for a charge, it will be kq over r squared, and for gravitational field, it will be gm over r squared. So mathematically, they are very similar. Well, they are the same. Both fields can produce attractive forces, yes, but gravity can't, as far as we know, have repulsive forces. So both fields can produce repulsive forces? No, not both fields. Only charge produces repulsion. Okay, so that's where you're looking for. This is the, which is not correct. So whenever they have not, look for it. Make sure you're not answering it in reverse. Both fields produce forces that obey the inverse square law. Well, this is an inverse square law of the fields. Yes, 1 over r squared. So the answer is C. Both fields cannot produce repulsive forces. Question 4. The graph shows the binding energy per nucleon. Okay? How it varies with the number of nucleons. So you've got the number of nucleons on the horizontal axis and binding energy per nucleon, which is basically the stability curve for nucleons, for isotopes, okay, different nuclei. The positions of 3 isotopes, P, Q, and R, are of interest in this curve, and they want to know which row lists the isotopes from the least stable to the most stable. So whichever is highest is the most stable. So Q is what you're looking for. Q is the most stable, so it's got to be B or D, and P is the lowest, so P is the least stable, so it's got to be in that order. So that shows you the answer is B. Okay, so very simply, most stable, yeah, is basically how high up they are on the stability curve. Question 5, they want you to use trigonometric parallax methods to determine the distance to stars. So that's basically looking at the Earth 6 months apart when it's the opposite side of the sun, and we know the distance to the sun, so you can make a right angle triangle with a distant star and see how the angle subtended against background stars, which are further away and don't appear to be moving, how this moves to the left and to the right relative to the background stars. Okay, and once you know the difference in the angle, you can measure it, and they can measure quite accurate angles these days. It allows the astronomers to work out the distance to the star. Okay, so by the angle, so they measure the angle, and they know the distance, so they know the distance from the Earth to the sun, and therefore they can work out by trigonometry the distance from the sun to the distant star, okay, or to the star. So the answer is the distance between sun and a nearby star. No, we don't need to know that. You can see it's 3 right angle triangles. That's not correct. The diameter of the sun is irrelevant. What we do need to know, the distance between the sun and the Earth, which is about 148 million kilometers. We do not need to know the diameter of either of the objects. So this is just a knowledge question. And I made each of my students do a presentation on an area of the astrophysics course, and they became experts in one area. So Zaid, I expected you to get this one right. I hope you did. Question 6. A container filled a mixture of two gases X and Y. The root mean square velocity of molecules in gas X is twice the root mean square velocity of molecules in gas Y. So root mean square means you square them, you mean them, and square root them, so you come back to a kind of average in meters per second. So the answer is going to be in meters per second. So the equation that is on the back of the exam is how the mean kinetic energy using the mean square velocity. So the mean square velocity is this. So that's the mean square velocity, and then you want the square root of that, the positive square root, obviously. So you can see that for x, half mx cx squared must equal half my cy squared. The second m is meant to have a y in there. So you can cancel out the halves, and you come up with a nice relationship, between the ratio of the masses and the ratio of the speeds. And since we know the ratio of speeds is 2 to 1, you can put those in. So we 1 squared over 2 squared, so it's 1 over 4, so the answer is A. I hope that makes sense to you. They want you to work out the ratio of the mass of X over the mass of Y, which is that. Okay? So it's just ratios. A lot of multiple choice questions are based on ratios and knowing which equation to use and just being good at doing algebra. So question 7 is about Hubble constant, H0. Initially it was estimated to be this value. So remember, Hubble's constant is the ratio between the velocity to distance. So the ratio was H0 was equal to V over D. So initially that gradient was given in, so because this is meters per second in SI units and this is meters, so you know that you're dividing meters per second by meters, so the answer will be in seconds to the -1, Hubble's constant. So that's why the unit is seconds to the -1. So you can then inverse that and get a time, because 1 over s to the -1 is seconds, and that is an estimate of the age of the universe based on Hubble's law. Okay, so that's something you need to do. So you got to work out what the approximate age of the universe is in seconds. Is the easiest, and then now they estimate H0, they're saying, to be higher than what they had before. So it's gone from 1.5 times 10 to the -17 to 2.1 times 10 to the -18. So don't get confused with your powers. You do that again, put the values in again, this time for the second value, I call it T dash. Okay, put the values in, you get 4.76 times 10 to the 17, and they want you to know which of the following is the age of the universe using the value of H0. So in other words, they want you to see how much is increased or decreased or whatever. Okay, so you've got to use that value. So you just do the second answer divided by the first answer, you'll get 7.14, which shows you the answer is D. Okay, so that's good revision of the age of the universe. Sometimes they don't give you SI units. You also need to go and learn how to change it from the distances in, for example, megaparsecs. Okay, so you need to know what megaparsecs are. Okay, so you need to go and learn the different units for distance and velocities used, because obviously meters per second will be tiny. Although they could have used standard form, that would have been less confusing for students at A level. So change it. Units are very useful in working out answers. Okay, so you can look at the units and tell if you're on the right track or not. So here you got a pendulum, and they put a paper cone on it. So what's the paper cone for? Is to create some light damping. So there'll be some light damping due to the paper cone. Because obviously light damping means more air resistance. The pendulum is displaced and set into oscillations. Yes, so now my students, I hope you understand why I started you with this experiment when you were in year 12. Plasticine is then added to the paper cone to increase the mass of the pendulum. Now obviously the mass of the pendulum does not affect the period of the pendulum. The only thing that affects the period of the pendulum is the equation T equals 2 pi, which is a constant, square root of the length divided by gravity. So gravity hasn't changed, the length hasn't changed, so the period and the therefore the frequency do not change, but you have got more inertia and more energy in the system because you've increased the mass, so the air resistance will have to do more work to slow it down. So the pendulum sets into oscillation again, and it says which of the following is correct for the paper cone with the plasticine, okay? The frequency has decreased, no, it stays the same as I explained because it's all to do with only the length is constant. Gravity hasn't changed, 2 pi hasn't changed. So it's going to be C or D, and it says the amplitude will decrease more quickly. Well, if there's more mass, it's got more energy, it's got more inertia, so it's going to take longer to slow down. So the answer is it will decrease more slowly. Yeah, so that little bit of paper cone is not going to be able to slow down a big mass as easily as it can a lighter mass. Okay, so it's basically Newton's second law in action, trying to change its momentum. Question 9, due to tidal action, the moon is slowly moving away from the Earth. Doesn't matter, you don't need to think about it, they're just giving you a fact. As the moon moves away from the Earth, yeah, the gravitational force between the Earth and the moon changes. Yeah, obviously it's going to go down, so the gravitational force between the Earth and the moon, we know G equals gm over r squared, yeah, and the potential energy of the moon also changes. Well, it's going further from the moon, and you just from your GCSE knowledge, you know if you increase the distance, you increase the potential energy. So this is quite an easy question because it's just conceptual, no maths involved, don't have to spend time on it. The only one with 2 ticks is therefore B. Question 10, the last multiple choice question. It says energy is supplied at a constant rate to a material. Constant rate means time, so the bigger the time, the more energy you've given. Okay, the material is initially solid, so we're going from time 0 here, increasing time, melting it, and then eventually boiling it into a gas. Okay, as energy is supplied, that means moving right on the curve, the solid melts, forms a liquid, then finally liquid turns into a gas, as I explained. The mass remains constant during the heating process. The graph shows a change in temperature. Okay, so obviously in horizontal portions from your GCSE knowledge, you will know that that is latent heat and bond weakening, bond breaking. So which of the following is correct? The specific heat capacity of the solid is greater than the specific capacity of the liquid. We just think of water. The solid is less, and you can tell from the gradients which one takes more energies for the same amount of mass, which one takes more time. Time is equivalent to energy, yes? So you're probably supplying the energy electrically, so it's voltage times current times time, yes? So if it takes more time, it takes more energy, therefore it has more specific capacity if it's a liquid. So then it says the specific capacity of solid is greater than the gas. Well, they look like the same gradient to me, so I couldn't tell exactly without measuring it. That's why I put question marks, but they're about the same, I can tell. Third one says specific capacity of the solid equals the specific capacity of the liquid. Well, we've already discussed that. A different steepness means they're not equal, and therefore the answer must be D. The specific heat capacity of the solid is more or less the same as the specific capacity of the gas because they have the steepness. So it's all to do with analysing the steepness of the gradient. D. Nice, easy question. I think question 6 was the trickiest, yeah, in this multiple choice run through. I hope you found that useful. I'm going to take a break, upload this, and then start with the structured questions to allow you to watch each video. I'll put them in the same playlist, so make sure you subscribe if you want to know when the next video is uploaded. and make sure you show your appreciation by liking each video and sharing it with friends. And also, if you know people doing linear, tell them about the international A-level papers being good for their practice, because there are way more papers for them to practice. I am trying to do some linear papers as well. If you are linear students, go and have a look. There are a few playlists in there where linear papers are being added gradually. Okay, I think that's about it. There's one more thing, which is now we have a membership program that if you want to ask questions and you're a member, your questions will be answered as a matter of priority compared to others. I get quite a few questions just in the comments, which is fine, but I can't always get around to them. For example, yesterday I needed to take a day off just because of the number of hours I've been working. So I hope you do appreciate there is a slight charge for being a member, but members will get priority treatment. Okay, thanks for watching. Bye for now.